I welcome you all for the lecture session EC 8501 Digital Communication Regulation 2017 for third year 5th semester ECE. We are going to see some terminologies in Unit 1 Information Theory. Course overview. The course objectives are to understand and apply the principle of source coding in information theory, to know about the quantization and various waveform coding schemes, to learn the various baseband transmission schemes, to understand and obtain the bit error rate of bandpass signaling schemes, to know the fundamentals of channel coding. The course prerequisites are sampling and quantization, modulation and mathematics. Course outcomes. By the end of this course, the student will be able to apply the knowledge of source coding in the field of digital communication, create the various line coding schemes to avoid interferences in communication, analyze the distortion through various baseband transmission schemes, apply the digital modulation schemes in wireless transmission and reception, analyze the data rates of transmission and digital communication, demonstrate the techniques of reconstructing the transmitted information at the receiver. The course outline is information theory. What is information? Axioms of information, information source, information content of a discrete memoryless source, information content of a symbol, entropy, information rate, discrete memoryless channel. Introduction. The purpose of communication system is to carry information bearing the baseband signals from one place to another placed over a communication channel. Actually, the information theory is the mathematical modeling to analyze the communication system rather than with the physical sources and physical channels. Two important elements in this theory are binary source and binary symmetric channel. In binary source, the symbols are in the form of binary digits. They are generated randomly. For the binary symmetric channel, it is a medium through which it is possible to transmit one symbol per unit time. As it is a binary symmetric channel, the probability lies between 0 to 1 by 2. Here we have only the data in the form of zeros and ones. So the probability lies between 0 to 1 by 2. If the information rate of a given source does not exceed the capacity of a given channel, then there comes the importance of the source coding techniques that makes possible transmission through this unreliable channel with a lower error rate. What is information? Information of an event depends only on its probability of occurrence and does not depend on its content. The randomness of happening of an event and the probability of its prediction as a news is known as information. Actually, the information which occurs very rarely contains maximum information compared to the event which occurs frequently. Axioms of information. Information is a non-negative quantity. If an event has probability 1, that is, the information is known. So the information is already known, so it is equal to 0. If two independent events occur, then the information we get from observing the events is sum of the two information. So I of P1, P2 is equal to I of P1 plus I of P2. Information source. An information source may be viewed as a object which produces an event, the outcome of which is selected all random according to a probability distribution. The information source can be with memory or with memoryless. A source with memory is the one for which the current symbol depends on the previous symbol, whereas for memoryless source, the current symbol does not depend on the previous symbol. So a discrete memoryless source can be characterized by the list of symbol, probability assignment of these symbols and specification of the rate of generating these symbols by the source. Information content of a discrete memoryless source. The amount of information contained in an event is closely related to its uncertainty. A mathematical measure of information should be a function of probability of the outcome and should satisfy the following axioms. Information should be proportional to the uncertainty of an outcome. Information contained in independent outcomes should get added up. Logarithmic measure of information. So the information is represented by I of xi for the symbol xi, which is equal to log to the base b p of xi, where p of xi is the probability of the occurrence of the symbol xi. So for any two independent source images, we are taking xi and xj. Then the probability, we have to consider the joint probability p of xi comma xj, so pi pj. So that the information given, the information is to added up by ii plus ij is equal to iij. The unit of I of xi is the bit. If the base is 2, it is discrete if the base is 10 and it is nat if the base is e. So it is standard to use the base as 2. So log to the base 2a is determined by log a by log 2 bits. Entropy. Entropy is nothing but a measure of average information, that is a measure of uncertainty in a random variable. The entropy is a measure of amount of uncertainty associated with the value of x, which is represented by h of x, which is given by h of x is equal to ensemble of I of xi, which is equal to minus summation p of xi into I of xi, where I of xi is log to the base 2 p of xi bits per symbol. Entropy for binary source. The source entropy h of x satisfies the relation 0 less than or equal to h of x less than or equal to log to the base 2 m, where m is the size of the alphabet source x. So these are the properties of entropy. Where all the events are equally likely, the average uncertainty must be largest value. So log to the base 2 m should be greater than or equal to h of x. H of x is equal to 0 if p of x is equal to 0 less than the 1. Information rate. If the time with at which the x emits the symbols is r, the information rate capital R of the source is given by r. Capital R is equal to r into h of x, where small r denotes the symbols and capital R denotes the information rate. Discrete memberless channels. A channel representation is done by a communication channel. As the name specifies, this is a medium through which the symbols flow to the receiver end. A channel is completely specified by a complete set of transition probabilities. Here the output is y and the input is x you have to take. So the probability is called as the conditional probability of obtaining the output y for the input xi. So the probability is also known as channel transition probability, since we are dealing with the discrete memberless channel. So the matrix obtained is called as channel matrix. So x is the input and y is the output. These are the references. Thank you.